Hey there, calculus fans. One last quick video on this. I might have a separate one where I actually try to figure out how high I can hit a tennis ball, but I'll save that for another day. Let me know in the comments if you're interested in this. This is going to be more for my business math students or entry-level math students. Let's just look at a particular example where it takes 3 seconds from throw to catch. So we're going to start with the following formula. Negative 16 t squared, so I said 3 seconds, plus 48t. Let's have this be the height of the ball after I throw it. This is a really accurate model, and this would be where it takes 3 seconds, so it would be a little taller. This would actually come out to be 36 feet, if that had been the case. Okay, I said in the last video that the velocity is negative 32v plus 48. Let's find that from the definition. So the definition of velocity or derivative is the following. We're going to replace, and it's actually bad I used an h here. I should have been thinking about this. Let's call this f, and let's call this f prime. And what I'm asking students to do right now in our Math 112 course is to use the so-called definition of the derivative. And what that is this slope. So where students are fighting with this right now as we speak in my class, they've got some parabola. Sorry about that. They have 2 points, x and x plus h, and they're trying to find the average speed between those two, which is what this is. This is the average, what we would say average velocity between this time and this time. So think of it as like between 2 seconds and 2.01 seconds. And the closer the h gets to 0, the closer you get to accurate. And this thing right here is what you get if you simplify this formula and replace h with 0. So let's just we're going to run through the algebra one time. This is algebra everyone hates, but really isn't that bad. So step 1 is you write down the function. So here's the function f of t. You're going to write down the function twice. Let's run through it. So I'm going to leave a little blank wherever the t is. Plus 48 blank. There I have called on the function once. And I left a blank where the input was. Now I'm going to call on the function again. Negative 16 blank squared plus 48 blank. All divided by h. That's what that functional notation stuff's about. Now, when you call on it here, you're going to plug in a t plus h. T plus h. When you're over here, you're going to plug in a t. So someone gives you a function and they ask you to write down the formula for average velocity in general from t to t plus h. That's it. Which is just terrible the first few times you see this. You go, oh, it's awful. The good news is we're going to recognize some patterns very quickly in class, so we won't be here very long. But you're going to have to do this a few times, and so you need some advice. And the advice is that if you do everything right, everything from here will cancel, and this will cancel. And if those things don't happen, you've done something wrong. So now we're just going to take a sad song and make it better. We're going to clean this thing up. We have t plus h squared. That's what this is. And so we're going to have to do t plus h, t plus h. It's not that bad. It's going to be t squared. There's going to be an h squared. And there's going to be these middle terms. Kind of looks like a monkey face. There's the nose, there's the mouth, there's the eyebrows. Plus 2th plus h squared. And everything gets bad for a moment. It gets messy. But if we can just make it a little ways in, it's going to be nice. Now we're going to distribute that negative. And we're expecting that everything that comes out of the second parentheses will cancel. So that canceled, hooray. We're expecting this to cancel, but we're not there yet. So we're going to need to distribute this. And this is the worst part. Some students tell me that this is beyond them, but I think you're up to the challenge. It's not that bad. You don't have to do it very many times. If the worst thing in your life is you have to do this 6 times and once on an exam, it's not that bad. But this does give you the foundation of where a derivative comes from. Success. Everything canceled out of that. This canceled and this canceled. If they don't both cancel, something went wrong. And now we're hoping the h in the denominator cancels, and it is going to, because you can see each one of these has an h. That one actually has 2 h's in it. So you're going to be able to cancel 1 h out of each one. Some students tell me they like to write it like this. Just think of separating the fractions. You can take your pick of whichever thing you think is nicer. H over h is 1. They don't actually cancel, they just become 1. And this is negative 16h, and this is negative 32t. That's the average velocity between any 2 times, where this is your start and this is your end. Actually, I'm using t. T is your start, and t plus h is your end. But what I'd like to do is see what happens when h gets closer and closer to 0. And when h gets closer and closer to 0, you get negative 32t plus 48. And we call that the derivative. It's also the velocity. And it's also what I already told you it was. So there's finding the derivative from the original definition. What we're going to do in the days to come in our business math class is learn the shortcuts. Basically learn that there's this 2 right here that comes down. And because of the 2, the derivative of this always ends up being 2t. And that's what makes this a 32. But that's what we're going to do. Once we've learned the shortcuts, you don't often have to think about the definition. But that's where it all comes from. All right, hope you find that